Hello guys, welcome to my channel. So today we are going to discuss about the problems of chemical equilibrium. So before beginning, I would like to request, if you are new to the channel, please subscribe to our channel, share our videos such that knowledge spreads, and the content is entirely free. We are making free courses on NEET and IIT JEE especially. Okay, so let's begin with our video. So observe this problem. If the equilibrium constant for this particular reaction, that is N2 plus O2 gives rise to 2NO is K. They have given the equilibrium constant as K. The equilibrium constant for half N2 and half O2 gives rise to NO. This is NO only. Is what they have asked. So the options are given. So let us consider the first reaction here. That is N2 plus O2 is in equilibrium with 2NO. So let's write equilibrium constant. K is equal to, we know that stoichiometry is written as power divided by concentration of N2 and concentration of O2. So let us write for this reaction, that is half N2 plus half O2. Half N2 plus half O2 is in equilibrium with NO. So consider it as K prime. That is equal to concentration of NO to the power 1 by concentration of N2 power half and O2 power half. So consider this as equation 1 and this is equation 2. Now I will square equation 2 on both sides, squaring on both sides. Squaring on both sides. So K square, that is K prime square, is equal to NO square by N2 1 by 2 into 2, and here also O2 power half into 2. Half, what, 2 cancel, 2 cancel. So what we will get, now I'll write here, that is K square is equal to NO power 2 by N2 and O2. This is the final equation we got, right? So K prime square is this. Shall I erase this? Let me erase this. So K square is that. What about K prime? It will go to that side and it will be equal to square root of NO square by N2 and O2. So what about our K? K is equal to, we know, that is NO power 2 by N2 and O2. So if we compare these two reactions carefully, both are same, but here only root is added. So we can say that K is equal to square root of K prime. Can I write like this? Or K is equal to K prime power 1 by 2. So what would be the correct one? Correct one would be, this is option A is the correct answer. In this way you should solve this. So this example came in NEET 2017. So very important, this type of problems a lot of times they have asked. Okay, next problem is, see, read the question. Value of equilibrium constant for a reaction is 1.6 into 10 power 12. Okay, they have given equilibrium constant, so that is K. Given that K is equal to 1.6 into 10 power 12. So at equilibrium, system contains, what does the system contains at equilibrium? So see the options, mostly reactants, mostly products, all reactants, products and reactants. We know that equilibrium constant K is equal to rate of forward reaction by rate of backward reaction, right? This is the formula. So they have given this particular constant, it is 1.6 into 10 power 12. That is equal to rate of forward by rate of backward reaction. So if we simplify that, rate of forward reaction would be equal to 1.6 into 10 power 12 into rate of backward reaction. That means by looking at this, rate of forward reaction is much greater than rate of backward reaction. So if the rate of forward reaction is greater, we can say that product formation is greater than reactant formation. So this is the answer. So the correct option would be mostly products. So it is going towards the right direction, that is forward reaction. So the answer would be second option. Let's move on to next question. So they have given that N2 plus O2 gives rise to 2NO. Equilibrium constant is K1, and they have given another reaction, that is 2NO plus O2 is in equilibrium with NO2, which is K2. So they are asking what is K for this reaction. They are asking K for this reaction. Let's write the reactions again. Solution. So N2 plus O2 is in equilibrium with 2NO, and 2NO plus O2 is in equilibrium with 2NO2. So if we add these two reactions, 2NO will get cancelled. So we get N2 plus 2O2 is in equilibrium with 2NO2, right? This is the final reaction we got. So I already said, if we add any two reaction, then their equilibrium constants are multiplied. So the total K, that is the entire equilibrium constant, is equal to K1 into K2. Now we have to find out what is the K for this particular reaction. Now we need to divide this reaction by half. We need to divide this reaction by half. Okay, let's see what happens. Consider this is equation 3, this is 1, this is 2. Divide equation 3 by half. Okay, so I am writing this in reverse order. First of all, that is 2NO2 is in equilibrium with N2 plus O2, 2O2. So divide by 1 by 2 is in equilibrium, we will get half N2 here plus O2. Here also this cancel, and NO2 is in equilibrium with half N2 plus O2, half N2 plus O2. Now we will find out what is K here. Equilibrium constant K is equal to, we know that, N2 power half and O2 by NO2 concentration, right? So it is just looking like K1 into K2, right? Where is that K1 into K2? Yeah, this one, this equation. Observe these two. When you observe these two equations, just reversed. Observe this equation. So exactly its square root we will get. So that is equal to K is equal to 1 by K1 into K2 whole power 1 by 2, or square root of 1 by 2. Exactly it will be like that. K1 into K2. K is equal to K1 into K2. See this reaction and compare this reaction with this reaction. Here we got 2 NO2. Here we got only 1 NO2, and it is giving rise to the corresponding products. This reaction is exactly halved. Now what about equilibrium constant K? Like previous problem, we have solved K is equal to K power, K dash, square root of K dash, right? Similarly that also, right? This is the answer. See this next question. They have given hydrogen iodide is in equilibrium with this corresponding hydrogen and as well as the iodine molecular form, and these two they have given, and they have given the rate constant of this particular reaction is 8.0. What would be the rate constant for this reaction, they are asking. So let us derive its equilibrium constant for this one. Equilibrium constant K is equal to, for that one, H2 to the power of 1 by 2 and I2 to the power of 1 by 2 would be equal to what? You know that concentration of HI and its power is 1. Let's write this equilibrium constant for this K prime. So K prime would be equal to H2 and I2 by HI square. What if I reverse this? That is 1 by K prime is equal to HI square by H2 and I2. Now compare this K, that is equation 1, consider this equation 1 and this is as equation 2. Compare these two. So this is equation 1 and this is equation 2. On squaring of equation 1 both sides, what we will get? Let's see. Squaring on both sides, what we will get? K square is equal to H2 power square into 1 by 2, and similarly for I2 we will get same HI square will get, right? So now square root, this one get cancelled. Now we will get k square is equal to h2 I2 by hi square, right? Hi square. Now what is k prime? K prime, when we compare equation 2 with this one, consider this is equation 3. Now compare equation 2 with this. Just it is inverse, right? Just it is inverse. So we can say that k prime is equal to 1 by k square. Can we write like that? Yes, just it is the inverse of it. Observe it carefully, equation 2 and 3. Now what is k? They have given the value of k is 8. So it will be 8 square. That means 1 by 64 is the answer. 1 by 64 is the answer for k prime for this particular reaction. So if they give this type of questions, we should solve like this. Very easy there. The equation seems to be easy, right? And the solution is also a little bit easy. Compare this equation. So here they have taken 1 mole of HI. Here we got 2 moles of HI. So we can say that it is exactly half, right? It is exactly half. So but the reaction doesn't work like that. Why? Because we are calculating equilibrium constant, not rate constant. Rate constant we are not calculating. That is the difference here. Okay. So I hope you have liked this video. If you like this video, please subscribe our channel, like, and please share it. Thank you very much.